orbit. And Mercury was and Messenger rather, was a very good name for a spacecraft to send to Mercury. That is because Mercury was the messenger god in ancient times. So NASA chose a very good name for that. And we are looking at the end, the day-night side of the Terminator, which is right there. And this, because of this, Mercury has, in its lack of atmosphere, has a very large temperature delta between the hot side, the side that's facing the sun, and the cold side. So on sides facing the sun, the daylight side, you get up to 800 degrees. And then on the other side, it's negative 300 degrees. So a very big temperature difference there. You need a very good spacesuit to go to Mercury. But Mercury is not the hottest planet in the solar system. Does anybody know what planet gets that title? Venus, yes, very good. And Venus is our next destination. So Venus gets this title because of its significant atmosphere. So, if you can, hold your hands out in front of you and give them a gentle wave. And get a little feel for our air pressure here on Earth. We're very used to it. You might, if you've ever stuck your hand out the window of a moving car, you might have gotten a little bit better feel of our air pressure. But our air pressure here on Earth, about 14 pounds per square inch of pressure. On Venus, it's 91 times that. It'd be like having over 300 African elephants sitting on top of you as you try to breathe. So pretty uncomfortable. And this atmosphere is mostly carbon dioxide. So this is just the stuff you breathe out. And this acts like a gigantic blanket, trapping all of the heat on Venus, making it so hot that you could actually melt lead on the surface. So a pretty uncomfortable time. And another uncomfortable thing is you see all these clouds right here. These clouds are actually sulfuric acid clouds. So another reason probably why you wouldn't want to visit. But we can strip those clouds away and get a better look at the surface. And we're doing this through radar imagery. So if you look through a telescope, you would just see that cloudy surface. But by using radar, we can actually get an elevation map of the surface. So these brighter regions here are higher in elevation than these darker regions down here, which are lower in elevation. So Venus is similar in size and composition to the Earth. And that, combined with all the not very good things I've said about it, give it its nickname, Earth's evil twin. But it does have one redeeming feature, and that's the fact that its day is longer than its year. Meaning every day would be your birthday on Venus. So probably a pretty expensive trip. So Venus and Mercury have one thing in common, and that's the fact that they both do not have a moon. But our next destination is a moon, and it is Earth's moon.
Venus is the second hottest planet.
So, you probably have heard a lot about Earth's moon recently. So anyone tell me why you might have heard a lot about it? Found ice on its poles. That's one I wasn't even going to talk about. But yes, that is the thing that that is one of the things. Shackleton crater on one of the poles of the moon. And I'll talk a little bit more about that. But one of the things that happened just recently was the 50th anniversary of Apollo 11. And so what we're actually going to do is show you where all of those different landing sites for all the Apollo landings were on the moon. And on Apollo 11, you can notice that it's sort of on the edge of this darker region here, which is a mare, which is Latin for sea. And mare are flatter than the highland regions, which are the brighter regions of the moon. And this seems like a pretty good place if you want to land somewhere on the moon, because you probably want a pretty flat place to land if you're going to try to fly a spacecraft down there. And I'm glad someone mentioned water ice on the poles of the moon. And this is the target destination for the future program that we're going to send to the moon, which is Artemis. So in the craters near the poles of the moons, we'll see if we can try to get a decent view of them. and I think some of them are trying to hide in the nighttime. But these craters there are actually spots where they never see sunlight. And this is very good because then, like as someone just pointed out a couple minutes ago, that you can have water ice there. And this is one of the destinations for our program to go back to the moon, that being Artemis. Hopefully getting there in 5 years is the current goal. And the main goals are to keep humans on the moon for a long period of time, so having water there is certainly a good feature, and also to land the first woman on the moon. Both have taken long enough to happen. And that program is really a stepping stone program to get us to our next big destination for human exploration, which is, you know, Mars. Yes, very good. We'll come back to the Earth, don't worry. So Mars is oftentimes, it has many nicknames, one of which being the red planet. You might want to tell me why it gets that nickname. Because it's red. That's the answer I get. I used to say every show, but some people in the last show didn't say it, so almost every show. And that red color is caused by iron oxide, or rust, in its soil. And we're going to try to get a view of some of the different surface features of Mars. And what just came into the daylight side there is the largest volcano in the solar system, Olympus Mons. And I will circle that for you. Olympus Mons, right there. So for a start, Olympus Mons is very tall, about 3 times taller than Mount Everest. So already very tall. And it's a volcano, a shield volcano, meaning its fused material very slowly. So its slope is only about 5 degrees. So the slope of the stairs to get to your seats today is 6 times greater than the slope of Olympus Mons. And that is a mouthful of S's to say right there. And another interesting thing is its surface area. So all of this area is Olympus Mons. And this would actually cover the whole entire state of Arizona. And probably, I think the most interesting fact about Olympus Mons is if you were to stand on the edge here and look towards the peak of the summit, you actually wouldn't be able to see it due to the curvature of Mars. So just imagine that, trying to start up your climb up a mountain, and at the edge of the mountain you can't even see the peak you're trying to get to. And we're going to go point out another feature on the surface of Mars. We're going to fly over some very large volcanoes. Those are the second, third, and fourth largest volcanoes in the solar system. And we're going to get to this gigantic, what looks like a scratch on the surface of Mars. And this is Mars's Grand Canyon. Although it is much grander than our Grand Canyon we have here in the United States. For a start, it's about 5 times deeper than our Grand Canyon and much, much longer. It would actually go all the way across the United States. And we believe this was caused by a tectonic crack as Mars was forming, and then widened by both wind and water erosion. So wind in the present and water in the past, because we do believe Mars had liquid water on its surface earlier in its history. And I can show you what that might have looked like. So there is Mars with liquid water on its surface. So as we fly a little bit further away from Mars, we can get a better view of Mars' 2 moons. So we have Phobos right there and Deimos right there. And these are named, their names translate to fear and panic. Although these moons aren't that scary, they just look like gigantic potatoes. So there's not too much to worry about. And Phobos is probably either going to crash into the surface of Mars or maybe even leave a ring around Mars in about 50 million years. And Deimos is slowly spiraling away from Mars and will probably end up out in the asteroid belt. And you're going to start to see some colored dots start to appear. And these colored dots are all asteroids in the asteroid belt that we have found. And we are about to fly through the asteroid belt. And don't worry, we should not hit anything, because unlike movies and TV shows, it's quite spread out. looks like we made it through all right. And next is Jupiter. Yes, very good. So Jupiter is the largest planet in our solar system. And one of the things you might notice about Jupiter is this faint little line here. It's sort of difficult to see, but does anybody have a guess as to what that little halo-y line thing might be? A ring, yes. Actually, all of the gas giants, not just Saturn, have a ring. And Jupiter is very large, largest in our solar system. Does anybody know how many Earths we could fit inside of Jupiter?
1,300.
1,300. Somebody has exactly the number I was going to say. Yes, 1,300. Very good. Should almost give you a sticker or something. And one of the features we can see on Jupiter is right here. And you've probably heard of this being the Great Red Spot right there. So the Great Red Spot we've observed for well over 300 years. And in that time, we found that it's been shrinking. So when we first saw the Great Red Spot, we think it was about the size of 2 to 3 Earths across. And now it's only about the size of 1 Earth across. And at the current rate it's shrinking, it will probably be gone within our own lifetimes. So it's a good time to see if you can go see Jupiter in some binoculars or a small telescope. It's one of the brightest objects in the southern sky right now. And we are going to fly away from Jupiter a little bit and start to get a view of its moons. So anybody have a guess about how many moons Jupiter has? I'm hearing answers in the 60, 62, 63. You're pretty close, but it's actually a little bit more than that now. The current best number that we have is 79. And they keep adding to that all the time. So I think those last couple of ones just got announced just a couple of months ago, so very, very recent. And we'll just quickly mention the 4 largest of those moons. You might have heard of those before. Those are the Galilean moons. And those orbits are in the colors that you see there. And in no particular order, those are Callisto, Ganymede, Io, and Europa. And if you take a binocular or a telescope and point it at Jupiter, you might get to see several of those, or if you're very lucky, even all 4 at once. And these moons were discovered by Galileo in 1610, which is why they're called the Galilean moons. And they are also some of the largest moons in our solar system. So while Jupiter is the largest planet, and it also has the most moons, it's probably not the most beautiful planet in the solar system. And that title probably arguably goes to Saturn. Yes, I heard somebody say it right before I get to it, but yes, Saturn. And Saturn is our next destination. So you might be able to argue that Saturn is not the most beautiful planet in the solar system, but what you can't argue about is the fact that it is the least dense planet in the solar system. It's actually less dense than water. And what that means is if you had a gigantic bathtub and somehow you could set Saturn in it, it would actually float. Although it probably would leave a very nasty ring. So let's talk about those rings a moment after you get a second to process my bad joke. So these rings are not actually solid. They're actually made out of many, many pieces of rock and water ice. And these particles range in size from smaller than you can see to about the size of your house. And these rings are also very thin. We can actually fly through them there. See, they're only about 30 feet thick. So it's very impressive that we can see them at all. And we're going to go fly over one of the poles of Saturn to get a little bit better view of its rings. And you might also notice a very interesting feature of the pole of Saturn. There is a shape there. What shape is that? Hexagon. Yes, very good. So that's sort of interesting. Most of the things we see in the solar system or in space in general are sort of flat disc or circular shape, like Saturn's rings, or a spherical or like a ball-ish shape, you can think about it like Saturn is, or just irregular. They don't have a good shape that we can call them. But we have this nearly perfect hexagon on Saturn's pole, and this is caused by the rotating winds around Saturn's pole. These have different wind speeds, and the result of those different wind speeds interacting with each other is this beautiful hexagon shape. And another thing you might notice about Saturn's rings is there are some gaps in those rings, otherwise known as divisions. And some of these divisions are in part caused by Saturn's moons. You may have to guess by how many moons Saturn has. I'll give you a hint, it's less than Jupiter. I heard 8. A little bit more than 8. You're 18, a little bit more than that. It's a little bit over 60 moons. And we sent a 13-year-long mission to Saturn and its moons, and that was Cassini. And Cassini's 13-year-long mission was from 2004 to 2017. And what you're seeing drawn right now are all the different orbits that Cassini did around Saturn. And in a moment here, you'll start to change color, and those different colors represent the different mission phases. So one of the things that Cassini did was fly by a lot of Saturn's moons, and they did flybys multiple times. One of the moons we learned a lot about was Enceladus, and Enceladus is an icy moon. This meaning it has a crust of ice and then liquid water ocean underneath of its surface. And you might be wondering how we know this is liquid water. Well, there was actually plumes of water ice that was spewing from the south pole of Enceladus. And Cassini actually flew through those plumes and used one of its instruments and detected water. So that's how we know it's actually water underneath of the surface. And anywhere there is water here on Earth, there is life. And so that is one of the best candidates for life outside of Earth in our solar system. Now, we haven't found any life there yet, but it is a very good chance. Although not life like us, probably just bacteria, but like cold, salty water. And to protect anything that might be out there, and to just make sure we don't contaminate any of the moons or the rings, and particularly Enceladus, we decided to actually crash Cassini into Saturn with this last mission phase in the lime green here, called the grand finale. So the grand finale was several close passes between Saturn and its rings, and then the last one they actually crashed Cassini into the atmosphere of Saturn to let it burn up so that we didn't contaminate any of the Saturn system. And we still have 2 more destinations to talk about. So, while we learned a lot about Saturn from Cassini, we know a lot less about our next 2 destinations. And our next destination is Uranus, or affectionately called Uranus sometimes. And because of that, it is often the butt of many jokes. But Uranus or Uranus was not actually going to be its first name. It was originally going to be named after King George III, and that was because it was found by a British astronomer, and King George III was the King of England at the time. And this is also interesting because it's the first planet that we discovered with a telescope. So all of our other planets that we saw today, you can just go out in the night sky if you're at the right time of the year and you're at the right time of night, you can just go see them with your naked eye. But Uranus is not like that. You actually have to have a telescope to go and see it. And so it was discovered by William Herschel when King George III was king. And it did get the name for King George III because it was a bit too political. Some of the other astronomers had problems with it, so it got the name Uranus instead. I know a much better name. So there are a couple of interesting things about it. And probably the most interesting is where its poles are. So the poles are tilted 97 degrees. So it's actually orbiting sort of on its side like this. So this is very different than the other planets in our solar system. This was probably caused from a collision with about an Earth-sized object earlier in Uranus's history. And we have gone to Uranus once, and that was with the Voyager 2 probe in the 1980s. And Voyager 2 also had another destination in the solar system, that being Neptune, the last planet in our solar system. And Neptune and Uranus are very similar. They're similar in size and also in composition. They're both mostly hydrogen helium with a little bit of methane. And one of the things you might notice here is that even though they're similar in composition, they look very different. They have a very different color. We actually don't know what's causing that. It's probably some chemical in the atmosphere that's changing this color that we haven't detected there yet. And while Neptune gets last place, it is the furthest planet from the sun, it gets first place title for one thing, and that is for fastest wind speeds. So the wind speeds here on Earth are about 250 miles an hour, the fastest we ever get. On Neptune, they get up to 1,200 miles an hour. That's faster than the speed of sound here on Earth. So very, very quick. Also visited by Voyager 2 in the 1980s, and we're going to bring up the moons of Neptune, because there is one moon in particular that is doing something kind of weird compared to the other ones. And I'm going to zoom out here, and give me a second to see if you can find which moon that is. And I'll give you a color, maybe that'll help. So, I'll tell you why it's sort of weird. So all of these moons right here are going around this way. And this moon, Triton, is going around the opposite way. So that's kind of weird. And Triton is a very large moon for going around backwards, otherwise known as retrograde. And this probably means that Triton was not formed with the rest of Neptune and its moons. It was probably formed in the Kuiper Belt and captured, stolen, and made one of its moons of Neptune. And the Kuiper Belt is sort of like the asteroid belt, many, many objects, but they're just beyond where Neptune is. And our next destination is actually in the Kuiper Belt. And that destination is everyone's favorite dwarf planet, Eris. I'm just kidding, do you think it's Pluto? Do you know more about Pluto? I think we should go visit Pluto instead. Don't worry, we were always going to go visit Pluto. So we learned a lot about Pluto. And that was thanks to a spacecraft we sent called New Horizons. And that was very recent, 2015 is when New Horizons flew by Pluto. And then it took us almost a year to get, or more, to get all of that data back because of how far away Pluto is. Pluto is 40 times further from the sun than Earth is. And we're going to see a very lovely feature here on Pluto. And you might recognize this as Pluto's heart, right there. I'm sure you've probably seen that before. But what you might not know is this region right here is a glacier region. And it's sort of slushy-like and geologically active. This region being Sputnik Planitia. And this is very interesting because we thought all the objects out in the Kuiper Belt, they were not geologically active, meaning that their surface didn't change. And Sputnik Planitia here on Pluto actually proved us wrong. So we learned a lot more about Pluto thanks to that and New Horizons. And as we fly away a little bit further, we will get to see, hopefully, yeah, there we go, Pluto's largest moon, that being Charon. Charon is about half the size of Pluto. Pluto already being quite small, only about 2/3 the size of our own moon. And because Charon and Pluto are so similar in size, Charon doesn't really orbit around Pluto. They sort of orbit around a point somewhere in here. They kind of wobble around at that point. So you could almost say they are sharing some space together. So that is almost the end of my bad jokes, as I'm sure some of you all are very happy to hear. I think there's only one more left. So I'm actually going to do is turn on the orbits of Pluto and all of the planets so that we can get a better idea as to what we have seen so far in our show. So there's a couple of quick things I'll point out about Pluto's orbit. And you can start to notice that all of the planets here in these colored orbits sort of are in a flat disk shape. And Pluto is not a part of that. It is inclined at an angle to that disk being the ecliptic plane. Another weird thing about Pluto's orbit is it actually crosses Neptune's orbit, meaning that sometimes Pluto is closer to the sun than Neptune. And I mentioned the Kuiper Belt a little bit earlier, and all of these dots that you're seeing out beyond that blue line right here, which is Neptune, all of these objects are objects in the Kuiper Belt. And you might notice this little cloud here, that is the asteroid belt very close to the sun in comparison. So I hope you remember those constellations from the beginning of the show, and if not, I will turn those back on again. And it's easy to think of these constellations and the stars in them as it being very two-dimensional, sort of like they're on our dome, being all the same distance apart. But in actuality, space is quite spacious. And so now we are seeing our galaxy, the Milky Way. And our Milky Way is a barred spiral with its bar right there and spiral arms. And we are part of the Orion subarm right there. And so this little green spiky ball that you see, that is all the stars that we see in our constellations. And you'll notice our galaxy is a sort of flat disk shape, just like our solar system. And that'll be important here in a moment. And so you're going to start seeing all of these dots. And these dots are actually other galaxies that we have surveyed before. Galaxies that could be similar to our own Milky Way galaxy, with billions of stars in each one of them. And many of these stars probably have planets. Currently, we've detected over 4,000 planets outside of our own solar system. And we will probably detect many, many more as we send more spacecraft and more telescopes up to look for those planets. And we're starting to see this butterfly shape now. And this is a consequence of the shape of our galaxy. So you might have noticed our galaxy, that flat pie, there was a lot of dust and things that were very difficult to look through. This is what we're looking at right in here. So this is what we're looking through the top and the bottom of our galaxy. So even in these regions that are blank here, there's probably as many galaxies in these regions as there are up here. They're just a lot more difficult for us to detect. And we're going to fly even further away here and get to this bubble. This bubble is the edge of the observable universe, as far as we can look away. To give you an idea, a sense of scale here, this is over 90 billion light years across. A light year being the distance that light travels in a whole entire year. It's about 6 trillion miles, sorry. And what we're looking at actually is the cosmic microwave background radiation. And this is essentially the light left over from the Big Bang, the start of our universe. But I won't leave you out here all the way outside of the edge of the observable universe. I'm actually going to fly you back through all of those galaxies, and we'll actually find our way back to Earth. So as we were taking our journey through the universe, there was a little particle of light taking its journey from the sun and moving out away from the sun at the fastest speed possible, the speed of light. Does anybody have a guess as to how far that little particle of light would have gotten by now?
On the center of the universe.
It wouldn't have gone very far. It actually wouldn't have even left our solar system. It would have gotten a little bit past Earth, and it actually would not have gotten to Jupiter. It would be almost to Jupiter right now, but not quite. So that just gives you a little bit of an idea that moving at the fastest speed possible, just starting in the center of our solar system at the sun, and how long it takes to get around. And this is due to a consequence of how large our universe is. And to give you an idea, just the closest star that we have to us is 4 light years away. So even if you're going at the fastest speed you could ever go, it's still going to take you 4 years to get there. And our current technology would take hundreds of thousands of years to get there. So I hope that gives you a little bit better context for how large our solar system is and how small we are here on Earth, our place in space. So with that, that does conclude our show. Thank you so much for